Hello and welcome everyone to a presentation on a new Elixir development environment that I've been working on for over a year. But before we get into it, I kind of want to explain what you're looking at first. This is something called Glamorous Toolkit. Glamorous Toolkit is a Pharo development environment that helps you visualize various software that you have, data that you have, and they have the ability to plug into programming languages. And in particular, I've been interested in getting up the Elixir programming language to talk to it because I believe that this development environment gives a lot of really nice features that will allow more advanced usages of development within Elixir. And I'd love to show this off to you. So the first thing that you do is that you start the bridge by running this command right here. So I'm just going to do it. Here I have a normal IEX that I spawned up, and I just turn on the bridge. And then on the Pharo side, we just connect it. So we run and we inspect this, and great, we have this. Now that we have this, I want to show what can you do? Well, I think the first thing that you can do is evaluate code. So I can evaluate this, and we get this data structure. And this may not seem too interesting. I can run the exact same things in here, and we can see that we get an event. And we can see from here that it looks like an event data structure. We have some event data structure. We have information like the author name, the body, the IP hash, stored name, stuff like that when it was added. But what's cool is that there's multiple views on it. Yes, we can look at it like that. Like we can look at it, we can see the author name, we can click on it, we can get the tuple of author name and who's doing it, right? We can get the events, and we can get some objects. I can even click on these objects. But let's kind of get down to what are these things that we're saying? These are things called views, and we can do a lot of things with views. For example, we have these events views here, and you can see that this is not my first time doing it because this was originally called event. Let's fix it. This doesn't update right away, but we can see that it's now called event instead of events. All I did was I went and I changed some text. I did this, and it recompiled. Pretty cool, isn't it? Further, we can see what are these here? Well, if we look at objects, we can see that they run through resolve. Okay, so we can resolve, and there's this play button. So I can do play and inspect, and it fails in this case because I'm running def outside of it. Let me try to run it from down here instead. We can see that we get these uploads here. So what's kind of neat is that I can kind of dig into it. So resolve, and then I can keep going list comments. What does list comments do? Well, we can see that list comments, we match the object, and then we have this enum.map. Okay, that's pretty cool. But we can also run things from down here too. So we can run this. I'm gonna kill this empty one, and we get the same results. Further, I can expand it like I did before. I can run anything really. So this is like a little notebook which persists. All of this stuff is old. Here's some Pharo stuff. I don't know. Apparently, if I run this, I get back my object. It turns out I do. How about that? Because again, I can run Smalltalk and Elixir, and I can run anything. I can even run 1+1. I can do a lot of things. So here's my little playground notes that you can see. We can also see the source. So you can see here's the source code. Here's what the source actually looks like. We can do other things too. I can add new functions. So if I click this button here, there's a new function. Let's say we take x. Let's say the default argument of x is 3, and we just return x. Not too interesting. We're going to hit Control S to save. You can note that something happened. And if I were to run the function with no arguments, we get back 3. If we run it with the default, which we will pass in the default, we get ourselves because we just pass back x. And then I can then delete it. But first, before that, I just want to show you that indeed we have the new function down here. We have the source code for it, and I can trash it. And we can see it's trashed. And if I were to try to even run new function, you can see it doesn't autocomplete. It doesn't do anything. Note that you get contextual auto-completion. So flow list is in the source, and we can see that we get these aliases here. So we can even do project store. There's a bunch of functions here. I can also just evaluate the module. And what's cool is that, well, we have the module, and it looks like this module is attached to a PID. So apparently this thing is attached to a process as well. I didn't know this. and you can look at the state. Apparently, the state is just WM2347. It's a map view. Not particularly interesting. But yeah, you can just kind of do that. And what's cool is in the Atom view, you can go to the meta and you can start programming. You can look at the source code. So we went from our event to the project store. Now we can look at code here and try to look at finding things by hash. I don't have a hash off the top of my head, so I'm not going to run it, but we can always do things like expand and change source code, as we saw, which I think is pretty neat. Note that not everything shows up, like the schema does not show up in this function view here, but the type does. We can see that our type here gets put here. So you can always do edits here as well and hit Control S to save. So that's, I think, fairly neat. You can also see who depends on you. So we have this event store, and it looks like we call on the project store, which we just looked at here. And if you looked at the project store's dependencies, wow, a lot of people call us. Project store calls upload, and a bunch of people calls us like event. I'm sure we can see event somewhere. Right here, events right here. So you can see the event calls this. And so you can kind of see who relies on who on like a kind of a first function basis. I got this view out of a nice article that shows you about compile time dependencies, which I found was rather neat to read. But we can do some other things too. Like we can go from this module to our application. So if I click this, we now have our application here. It's called local upload. We can look at its module tree, which this view isn't too interesting yet, but you can, for example, see all the modules in your project, and you can kind of just scroll through it. And what's cool is that we have a thing called examples. The examples in this project aren't too interesting, but it tells me that replay builds relies on append with projection. So I can show you append with projection is an example using our examples library. It's kind of a big one. And if I were to run it, you can see that something happened to my database, and we get some uploads with some comments. And I know that, well, there's another example called repay rebuilds, and I know that I can run this, and it uses the cached value of this, which I think is pretty neat. You can see that there's no messages here because we have rerun being false, so it automatically just uses the cache for our examples. Not particularly interesting. You can look at things like docs coverage. Docs coverage view takes a little bit to render, but we shall look at it. And what's neat is that anything in green has a module doc. So if I were to click on this, we can see that there's a module doc. But we can see that its functions don't have module docs. Like if I click on this random function right here, we can see that create does not have a module doc. We can see init has no module doc. And you can kind of just click around, call has no module doc. These are probably derived things, right, from using, I guess, a controller because this is a Phoenix application. So yeah, you're not going to get docs on those, but you can do that, and it's kind of cool. You can click on all these. Like endpoint has no documentation, has no module documentation, but yes, that is what it is. We can also see its compile dependencies, so I can look at what modules depend on what for compilation. So we can see that if I were to change upload, then it looks like this event thing will have to change. I know event store will have to change, event does, and therefore event store. That's not the most interesting view. Again, it's useful if you're trying to make your compile time dependencies faster, but let's look at some more interesting things. So we can look at what does our application depend on. So I believe this is under app dependencies. We can see that local upload is depend on all this. By the way, app dependencies you can also view from here as well. I just have to find it. Dependencies here. So we can see dependencies for local upload, so you can do it at an application level or a system level. So we can see that local upload relies on a thing called GTBridge. This is what allows us to run all this. GTBridge runs on something called the event broker, which then relies on example. And I can click on all these. And note, I can look at the modules of these. And what is neat, and something I've not really seen in any development environment before, is that I can go to, let's say, the GTBridge here, and let us try to go to something. So I can go to its source code, and I can look at rerun, and I can change it. And it is actually recompiling. And if I were to try to run it, and let's see, I don't care about this piece of code. Let's just ignore it. Well, I don't even have to say it. I can just call rerun. Note that there is a bug where I have to evaluate something first before it auto-completes local functions. We can see that, oops, I have to pass it an argument. It is, did I spell rerun wrong? Whoops. Well, maybe my aliasing does not work here. No big deal. We can always just run it like this and we get back false. So we know that for our dependencies, we can actually recompile our dependencies. And you might ask, why is this useful? Well, maybe you're working on something. Like, for example, let's say I'm working on this. We got here from this, by the way. All that was from here. Let me restore that. We went on this journey through the project all the way to the right, and we can go all the way back to where we started. It's rather wonderful. But, for example, what if I want to change title.txt? Maybe I don't like its behavior. Or maybe I think that there's a bug in a library that I'm using and I really don't want to go and check it out and then like make a change and then update my local program. Then there's no big deal. I can just go here and I can look and I can do a change. So let me make a really bad change. So I'm gonna revert this later. Let's just say the view title is hello. Very bad, by the way, because all our views are going to be called hello now. I believe if I update, yeah, you can see that this is called hello, which is pretty bad. It's not this one because there is a different one. I believe it's this one here. Yeah, we don't want to do this. I'm going to change it back so we do not have any issues, but I can do this. And so if you have an issue with your dependency in your big application and you don't want to go through the rigmarole of, oh no, do I have to go to my dependency? Do I have to go here? Nah, you can just edit it from here and it's actually changed on disk. Like for example, I can even show you where it's stored. So if we go to here and I were to delete it, I'm not gonna actually delete it. It tells you it's in my workspace, it's in my X locals in here. And so then I can push this and make a branch. If you clean your dependencies, this of course goes away. But what's neat is that if you don't clean your dependencies, it persists on restart. So if I were to kill my REPL here and restart it, it would still exist, which I think is really rad. But we can look at more things. We saw this earlier. But what you didn't see is how the Elixir works under the hood. So I can show this to you in two ways. One, I can just call this Atom here, but let's not do this. We know that we've been using something called the GT bridge. So this tool is called Spotter, and this lets me search my entire Smalltalk code and my Elixir code. So I have code here that lets me look at my application. So here I have the GT bridge, and I want to look at its supervision tree because we can see that we have this evaluation supervisor. So we can click it. And we can go to the PID and we get the same view. Isn't that cool? Look, I clicked here and I get this. So we can view it as an atom. Like, okay, here's an atom, here's the source code. Not too interesting because, again, it's just a dynamic supervisor. So if we look at its state, it's not too interesting either. It's a dynamic supervisor. I've not made any GUIs for it. We can make some GUIs for it, but we haven't. Note, by the way, which is interesting, is that when we saw over here, and we looked at these views, these GUIs were made in Elixir. But you can also make your GUIs in Smalltalk. So this API right here is made in Smalltalk, and here's the code for it. And I can show you that it's different, whereas if I change it, you can see that it automatically updates. Let's look at the expanded. I think that's pretty cool. So, as you can see, we can update it right away. But the interesting thing is that this is a lot like Observer. So this is not like Graph is or Dot where, oh no, I'm stuck with this. Because if you're using something like Livebook and there's Livebook views for supervisors, you get this wonderful thing, but then you're kind of stuck. So what I kind of want to look at is a random supervisor because, well, this is a dynamic supervisor. Let's look at its children. Well, okay, the PID is not too interesting. Okay, I don't know what to do with this. But I know what to do with the state, because the state is a GT bridge eval. And if we look at something, we can look at here that, oh, hey, this looks quite interesting. Self is bound to this event right here. What this means and what's interesting is that I believe this is actually the exact supervisor for this. So if I were to go here and I were to evaluate self, we can see that it looks like I found the supervisor for this. Every single page that you see here, every time you drag this up and you evaluate something, creates a brand new gen server to go under the supervision tree, which I think is cool. So if I were to drag this up and make a new one, this doesn't update dynamically, sadly. But we can also look at the source for GT Bridge Eval and maybe change it if we need to. But what's really cool is that we can just kind of look around our code base and be like, huh, what is all this? What is this xref code? What is this and that, right? We can just look at the state. Well, the state here isn't too interesting. Okay, it's ready. Wow. But we can look at its source for GT Bridge Ref. We can look at all the functions. We can see who calls on it. And we can kind of go from there. And what's cool is that, one, we didn't have to do that once we know the name. We can kind of just do evaluation supervisor. But I got it there from the GT Bridge, but I can also just look up evaluation supervisor. So if we look here, there's beam modules. So I can do enum, and we can see that, oh, hey, what are all these beam modules? There's ecto enum, there's enumerable, enumerable.map. I don't think any of these are good. I cannot sadly do that. This is a coding error on my end, but we can get back there in a second. Yes, there will probably be some bugs. I've tried my best to make it so that there's no bugs, but there's not everything you can do. One thing that's kind of a shame is that you don't always have source code for your modules in Elixir. But if it is something nice, so like for example, if I were to go back, let's close these windows. I did not mean to full screen it. Sorry for that. If we go back here, we can look at enum.at. Sorry, this looks like there's a little bug. Oh well, we can look here, and we can look in the coder here, and not all these are interesting, but I think I see what I did. Anyways, we have any here. And we can see its type signature. Like, oh, we can see element, enum as bool, boolean, etc. So if there's a type signature, we can kind of look at it and we can keep expanding. Like, what's an index? Okay, there's that. What's a default? The default is any. And we can kind of just look at documentation, much like an H function in Elixir. So I think there's a lot of really cool stuff that you can do, which I believe is very neat. GT Bridge presentation. Let's go back to a new page. Great. So yeah, we can do a lot of things. We can evaluate stuff. We can look at our application, and we can start looking at software that we care about. And I think this is probably the biggest thing, which is a win, is that we can really start to inspect our systems. Because although I like Observer, and for example, this view right here is taken directly from Observer, you still miss things, right? Like, it's still not perfect. There's many more things that I could show. If you want to look at any other aspects of the system, please let me know. I want to show maybe one last thing, which is how I do the wiring on the, I guess, Pharaoh side. Because, like, for example, there's some really cool things that we can do, like, check this. Like, no one probably cares about this but me, but if we look at the column list title here, I'm going to, by the way, this is hacking a dependency. We can see that I'm going to have 3 views of it. So there's one view here, one view there. I'm going to now save, and when I save, it takes a bit to compile because the entire dependency group compiles. Note that all the views update. You may ask, how is this done? Very simple, and that is we have an event-driven system. So we have all these modules here, and they basically have a module source cache, which sends out different recompilation. So there's different things that could be sent out, like the beam modules recompiled, the source is changed, stuff like that. And you can kind of see the life cycle of some of these views on, like, oh, what has really changed? Something that's cool, and I was trying to tackle with this, is with errors. So, again, one thing I can show off is that you can make functions. So let's make a function, and this is a perfectly valid function. Great, let's make it invalid. let's just try to cause an error in Elixir. What is a good example of an error? I think this will fail because it's yes, look, we did an error. So we have a coding error. We can see undefined variable y here, but we can open it up here, and it looks like I broke post-production here. I fixed the error that caused the errors not to pop up properly. So I can show it off. So what is rather cool is that you can do this. So if we cause an error, as before, we can see the little thing up here. But when you open, you can actually see what's wrong. It's not great. You still have to look down here for the message because this GUI's in its infancy. But I can then fix it. You can see it's fixed. Wonderful. I can make a more grievous change, though. So let's save. And this is a bad one because I introduced a second end. Note that we can't save it from the functions view, but again, we can open this up and fix it. If you're in the same module, this doesn't matter. This matters if you're hacking like some module, like if you broke like, oh no, I broke the module inside of here. Like I call another like project get upload and I made a bug, right? Like I called it in get upload and really we want to fix it in project store and maybe the GUI broke, right? Great. Note that I saved it and we can see that it's gone here too, by the way. One thing that I actually forgot to show off, and I think is a rather cool feature and something that I believe a lot of Elixir environments don't have, is that I can call this. So, okay, who references this function called title? Well, I can start looking. This guy does. This guy calls text.title. This guy calls text.title. I can actually look at all references of whoever in the code base calls text.title. I can even see who implements it. That's not too interesting as there's only one implementer, but you could imagine that if it is a interface, that it could be more interesting. I believe I do have some actually interesting examples to show this off of. I believe maybe I need to go to an upload though. You'll see why in a second. Let's start looking at some of these. I believe I have some dynamic, here we go, columned list. One I can, I believe, here's all the references to it, but I can right click and we can look at browse implementers. You can see Control M and Control N are the hotkeys for this. So you can see here that, hey, look, GT Bridge Flow Builder implements this. I've not seen, I've not been able to see LSP be able to do this. I think it works decently. You can see here for enum.at, who calls enum.at? A bunch of people call enum.at. This is probably not everything, so I don't think it's completely perfect, but it is something. At least you can figure out who calls enum.at. And what's I think really cool is that I can just start exploring code bases I have no idea. Like, what is the CC precompiler? What application is it even a part of? It's apparently called the CC precompiler, version 0.1.1.11. It looks like it is a NIF precompiler that uses C++, and it's connected via the Elixir Beam rig. Wonderful. I can look at what compilers do I have? I don't even know. Oh, it's a def-p. Note that this failed to work because it is a def-p. I wonder if I can just run this, though. I'm curious. No, I cannot, sadly. It looks like access.get does not allow me to do it for some reason. Oh, well. No big deal. Either I just think it's rather cool that I can just start exploring applications that I have never seen before. I just think it's really cool. Yes, so I'd like to thank everyone for your time, and I hope this has been a rather interesting development environment for everyone to play with. Thank you.